boys and girls, it's Miss Manning. Today I'm going to be teaching you Module 2, Lesson 3, where we're learning to write and interpret numerical expressions and compare the expressions using a visual model. And the visual model that we're talking about is a tape diagram. For us to do this, sorry, I can't talk and spell at the same time. For us to do this, we have to be able to identify keywords that we're going to come across when they're giving us a numerical expression in words. They're going to use words like times, which means to multiply, difference, which is keyword for subtraction, sum is a keyword for addition, and then you're going to see something like this. Like this is 4 twos. They have the number and then they have the number in word form. Well, if you think about 4 twos, that's like a repeated number sentence. And we know another way to write a repeated number sentence is to count up how many times you repeat that number. Four copies of 2 or 4 twos. So when you see something like this, it means that you're going to really stick a multiplication symbol in between the two. But remember, it's like that repeated number sentence. The other thing is we can identify numbers that go together, and they're going to be with keywords like of and between. So you'll see things like the sum of 25 and 12. What that means is when you're writing out this this expression, you're going to group together 25 and 12. Because if we're doing something else to the number, like say multiplying it, and you don't group those together with the parentheses, what you're going to end up doing first is multiplying, but they want to know the sum of those two numbers first and then make copies of them. So when we say go together, we mean with parentheses. Then it will also have the difference between. So it might say the difference between 5 and 3. So that just means, I know difference means subtraction, so it means 5 minus 3 is going to go together. And whatever we get, whatever that difference is, then we're going to then do something else to it. We also are going to be able to compare the expressions without evaluating them or solving them. We don't want to solve them. We want to look for similar numbers. So I'm going to give you a simple example here. If we saw 2 plus 5 and we wanted to compare it with greater than, less than, or equal to 2 plus 7, we don't actually have to solve these numbers to know which one is going to be the bigger sum or the bigger value. We're looking for similar numbers or repeating things. In this case, it would be plus 2. So really what we're looking at is 5 and 7. Which one's the bigger number? So if we can identify similar numbers or similar parts of the expressions, then we're able to solve it, or we're able to compare them without solving it. So for our mental math today, we're going to be working with the distributive property or decomposing factors. So factors means we're dealing with multiplication. And when we talk about decomposing, we talk about breaking it apart. We're going to be breaking apart some numbers using that distributive property. So right here, they've given us this multiplication sentence of 9 plus 3. They want us to break it apart, but we have to figure out which number they want us to break apart. Obviously, they've repeated times 3 in both of these. So the times 3 has stayed the same. The number that we're breaking apart is this 9. So let's think about this 9 as like a number bond. I know you guys did number bonds in 4th grade. So if 5 is one of our numbers for the number bond, what other number would we need to make up 9? That would be 4. So if we can solve 5 times 3 and then add that product together with 4 times 3, it's going to be the same answer that we would get with 9 times 3. This can come in handy when you have big numbers. It can come in handy if you don't know some of your basic facts and you have a hard time remembering it. So now we just solve the multiplication problems first because of PEMDAS. Remember, we first deal with our parentheses. So we're dealing with our numbers in the parentheses. So 4 times 3 is 12. And now we can add these two together pretty easily in our heads to get a total of 27. So let's get started with our first practice problem. They've given the problem to us, the expression in word form. So we have to identify those keywords like times and sum, but remember it's sum of. So that means that these two numbers are going to belong together. So we want the sum of 26 and 4 repeated 3 times. So first it's asking for a tape diagram. And we're going to repeat something 3 times in our tape diagram, and that something is the sum of 26 and 4. So if this part of my tape diagram is 26 and 4, then it leads you to believe that every piece of that is the sum of 26 and 4. Now we're going to write it as an expression, so we're going to write it out with our numbers. So we want to take 3 times or make 3 copies of, we can't just say 26 and 4 like we do here, because with PEMDAS, what I would do first is I would multiply 3 times 26, and that's not what the expression is saying. It's not saying 3 times 26 and the sum of 4. It wants us to find the sum of 26 and 4 and then make 3 copies of it, or 3 times, whatever you get first. So because of PEMDAS, what they want us to do first is find that sum. And the only way we can make sure that we add first is by adding those parentheses. And now they want us to find the value of the expression, which just means to solve it. So of course, we're going to start with those parentheses. So 26 plus 4 is 30. So now I have 3 times 30, which I can do by breaking this number apart into 3 times 10 if I wanted to. But I also have to remember this times 3 here. So I end up with 3 times 3, which is 9 times 10, which equals 90. So that's the value of this expression that we've written here and of this number sentence right here. All right, we have the sum of 2 12s and 4 3s. So we see that number and written number together. Remember I said that was like 2 different 12s, or a repeated number sentence. So it could be written as 2 times 12, and 4 3s would be written as 4 times 3. Now, when we're doing our tape diagram for this one, it's going to be looking a little bit different. So I need 2 12s. So I have 2, and each one has 12 in it. And then I need 4 3s. So these can be a little bit smaller. The size doesn't actually matter when it comes to your tape diagrams. It's more about what the content of what's in it, but you're not making 4 4s, we're making 4 3s. So I've got to go back and change that. So 4 3s, that would be our tape diagram. And we would need to solve for the total of that. But as an expression, they say sum of. So we know sum means multiplication, but also we know that it means that we're going to be grouping things together. So we need the sum of this and the sum of this. So we've got to figure out 2 12s, and we have 4 3s, but we want the sum of those two things. Now, if I were to just write it like this, PEMDAS would mean that I would multiply, and then add. But I think visually it looks better for you to say, I'm grouping these two numbers together, and I'm grouping those two numbers together. That, to me, when you're looking at that expression, is very clear that you want to multiply that first, then multiply that, and then add. So you don't necessarily need the parentheses in here, but I just think mathematically, it's a lot clearer. Now we need to find the value of that expression. So 2 times 12 is 24. And then we solve 4 times 3. Because of PEMDAS, we do our parentheses first. So 4 times 3 is 12. 24 plus 12 is 36. Another thing that they're going to ask you to do is go from the numerical expression like this to the word form. So we have to remember that when we say multiply, we can say times. When we see the subtraction symbol, we're going to say difference. So our number sentence might look like this. Oops. Might look like 8 times the difference. Now I want those two numbers to be grouped together, so I'm not just going to say difference, I'm going to say difference between 43, and 13. So that would be a way that you're going to take it from the numerical expression and then go to the opposite direction from what we've been doing and write it in word form. And the last thing that you're going to come across is this idea of comparing them. They want us to use tape diagrams to compare these. So we have 30 15s minus 1 15. So imagine we have 30 copies of 15, except for I'm not going to draw out 30 copies of 15. I'm going to say that there are 30 of them, and each one of them is 15, and we're going to take away 1. And this one is 29 15s. So again, I'm not going to draw out 29, but I know that the total is 29, and each one of those squares is equal to 15. So if I think of 30 15s minus 1 15, I think for this one, the tape diagram is helpful, but also if we were to write it out, so I want to group those two together. And then we have 29 times 15 is the expression here, obviously. So if we think about there's going to be 30 of those 15s, but we're going to take away one of those 15s, what we're left with is 29 15s. So we want to compare those two. Now, I didn't solve these to compare them. I was just trying to make sense of the numbers, and I'm looking for the repeated factor in these. In this case, it's 15. Both of those are 15. So really what we're comparing is 30 minus 1 and 29, which we find that they are equal to each other. So kind of get creative with all of the keywords and the tape diagrams and everything that you've been learning in this lesson when it comes to comparing these. That's all I have for you guys today. Make sure you're paying attention to those keywords and following the rules of PEMDAS. See ya.